Hello, my name is Daniel, and in this video I'm going to go over a few important parent functions. So to begin, in the upper left-hand corner, our reciprocal function looks like f of x equals 1 over x. And the domain of this function is all real numbers except 0. Since we're dividing by x here, we know that x can never be 0. Therefore, our domain here is negative infinity up to 0. We have a soft bracket because we do not include 0. Union 0 to positive infinity. The range of this function, if we look at our y values as they increase from negative infinity, so as y values come up this way, we see a trend that our y values get closer and closer and closer to 0. However, our y values never actually touch 0. Additionally, as y decreases from positive infinity, so as it comes down this way, we see the same trend that y gets closer and closer to 0, but y never actually is 0. Therefore, the range of our reciprocal function is negative infinity up to but not including 0, union 0 up to positive infinity. Our reciprocal function has symmetry with respect to the origin, and any function that has symmetry with respect to the origin is odd. Our next function down below is the absolute value function. This function looks like f of x equals the absolute value of x, and the domain of this function is all real numbers because we can take the absolute value of a negative number, we can take the absolute value of 0, and we can take the absolute value of a positive number. So therefore, the domain of our absolute value function is negative infinity up to positive infinity. The range of our absolute value function, however, is a little different. If we take the absolute value of a number, we will never get a negative number back. So if I take the absolute value of a negative number, it will become the positive number. If I take the absolute value of 0, it will only be 0. And if I take the absolute value of a positive number, it will stay the same. Therefore, we know that the lowest number that we're ever going to see in our range is going to be 0. So we can even see it graphically. The lowest number we're ever going to see is 0 right there. So our range for our absolute value function will look like a hard bracket here because we're including 0 now, up to positive infinity. Our absolute value function has symmetry with respect to the y-axis, and any function that has symmetry with respect to the y-axis is even. The last function that we have to the right here is our cubic function, and it looks like f of x equals x cubed, and the domain of this function is all real numbers. Because I can cube a negative number, I can cube 0, and I can cube a positive number. So therefore, our domain of our cubic function will be negative infinity to positive infinity. In the range of our cubic function, if we look at the graph real fast, we see that our y values increase from negative infinity coming up this way. Our y values pass through 0, it looks like, and then our y values continue to increase up toward positive infinity without bound. So therefore, the range of this function looks like negative infinity up to positive infinity. And our cubic function has symmetry with respect to the origin. So we'll say origin, symmetry. And any function that has symmetry with respect to the origin, like I said, is odd. So those are a few important parent functions. I hope this has been helpful. If you are still having trouble, please reach out to us for more help. Thanks for watching, and have a great day.